Let's now solve our first example on equivalence partitioning. You are testing a machine that scores exam papers and assigns grades. Based on the score achieved, the grades are as follows. So you are a teacher or an instructor, and these are the grades that we have. From 1 to 49, F, from 50 to 59, D minus, from 60 to 69, D, from 70 to 79, C, from 80 to 89, B, from 90 to 100, A. So how do we test this problem using equivalence partitioning? Let me bring my markers. So in equivalence partitioning, it is good that you begin to write your numbers line. You begin to draw your answers on the number line. So here, the first partition is from 1 to 49. The second partition begins at 50. The third partition begins at 60, 70, 80, 90, and 100. Okay, so these are 1, 2, 3, 4, 5, 6 partitions. So I will test at 6 values, each value from one partition. I might test at 25, 55, 62, this is here, and here we have 77, for example. Then we have 81, then we have 99, any value from each partition. So here we covered all the partitions. But did we really cover all the partitions? No. We should test the partition before 1 and the partition after 100. One might ask, why should we test after 100? It is impossible that any student will get a degree that is higher than 100. In this case, we should think of the problem as a software, not a real-world scenario. All of these values are only a field in our site or an application that you fill with numbers. Okay, so any person might write down -3 and press enter, or he might write down 107. Okay, so I need to know if the person or the user enters these values, what will happen to the system. Okay, this is not a normal behavior. No normal user will do this, but the user might make mistakes, or he might try to make the system goes into a crash state. So in this case, we must test before 1 and after 100. That's why we have 7 and 8. These are 2 other partitions. We might test, for example, at -5 and at 110 or any other value. So in this case, we achieved 100% equivalence partitioning. Okay, the 6 partitions in the middle are called valid partitions. Okay, these 6 partitions. And these 2, 7 and 8, are called invalid partitions.